And, does anyone have questions? You can ask questions from the quiz. Did everybody notice that I curved the grades? So if you look at your quiz grade, it's actually higher than the grade I put on the quiz. So when I got done, when I finished grading all the quizzes about an hour ago, then I curved them once I knew all the grades. And you can still make corrections on them, and the corrections are due the day of the final. I don't think I had put a due date for corrections on the syllabus because I hadn't really figured it out yet, I don't think. But we'll go ahead and make it the same as homework corrections. All the corrections are due the day of the final, so you can turn it in anytime. You can turn it in right now if you feel confident in any corrections you made. So does anyone have any questions about how that works or the quiz itself? Any questions from the quiz?
Can you do that last problem, number 4?
Okay, so.
Or something like it?
Yes. What's the equation of a line in general?
With the y equals x line, that way? Is that where
no, that's a very specific line. I want the equation of any line.
Oh, I don't want to get one.
So it's y equals mx.
Oh, y equals mx plus b, that one?
Okay, that's one equation. You could use that equation. Did I give you a way to figure out your slope? In that problem?
Yeah.
Yes, I did.
Oh, okay.
And that's the only reason that equation I gave you is sitting there. Once you get your slope, throw that equation away. You're done with that. Get out of here. Right? That's all it does. But some people were solving and then circling it like it meant something. No, that equation means barely shit to me. It just gives me my slope. And then I got a point that my line goes through. So once you know m, and you know the point, x and y, you can actually plug those in and figure out what b is. And that's all I'm going to say. I think that's more than I should have said, and that's all. You could use y. What's the other one? Y minus y1.
Oh, yeah. Y2 minus y1 over...
No.
Y that one? Oh, then I don't know. There's too many equations already.
There actually isn't. So the one you're about to say was a slope equation, right?
Yeah.
Y2 minus y1 over x2 minus x1 equals m, blah, blah, blah. Very quickly. I don't want to spend a lot of time with this, but do I have to use a specific point to make the slope for a straight line come out to be whatever it is? No, it doesn't. If I have one point, couldn't I use any other point on the line and the slope's the same? Are you with me? That's the definition of a line, basically. Is the slope doesn't change. The slope changed. Oops, not a line anymore. So if I replace the 2's, the y2 with just y, and the x2 with just x, multiply the x's up, I get y minus y1 equals m times x minus x1. That's the other equation of a line. It's called point slope. Sounds like a really boring movie without Keanu Reeves. Point Break, right? With is Keanu in that? It's been too long. Is that all right?
Yep, that makes sense.
Okay. How's everybody else? Any other burning questions from the quiz? No. Okay. My wall of names. I love this. It's just a wall of names. And I know Amber's there. And I'm pretty sure Brian is still there. Maybe Jason. All right.
Hell yeah, I'm still here.
Hell yeah. All right. So if you just came in and you didn't hear me say this earlier, the quiz corrections are due by the day of the final exam. You can turn them anytime before then. I curved the quiz grades. So the grade that's you see in Canvas is different from the grade you see that I wrote on your quiz. So it should be higher. It's a curved grade. The average still came out to below 70 after the curve. But after everybody makes corrections, that could go up by quite a bit. So make corrections. It never makes sense to me, the people that don't make corrections to anything. I'm like, what the hell? I wish my teachers would have done anything like that. Holy shit. Anyway, all right. Anything from homework then, if we're done with the quiz? Anything from homework problems?
have a bunch more if no one wants to take you up on your offer.
Good.
So for 3.1, I still need help with the calculator problems.
Oh, good. Somebody else has asked me about that, and I said, please remind me, because I was a real asshole yesterday, and I said, she's got a question. Forget it. Which one was that? That was like towards the end, right? 70 something?
78 is the first one, but I'm hoping if you just help with, yeah, that I can figure out the rest.
So here's where we get exciting. I should have gave my, I got to give my cord some more room so I can do this. Oh, the beauty of making technology work. So this is going to get kind of exciting. We're going to take a trip here. You are unleashed. Oh, you can see my messy house. All right. Now I'm going to have to, this is going to get interesting for me. Hold on. I know it's blurry. Give me a second. That's better, right? So you can see a bunch of shit from earlier. Okay, so that's the TI calculator, right? Soup. So I think I was looking at the survey, which not everybody has done yet, and I forgot to send an email reminder out, but let me just say this right now. Please do the survey. But I think only 2 of the people that replied said they had never used one of these before. Everybody else said they've at least used it a bit, if not a lot. So we are going to use this TI calculator a decent amount. So one of the most, so you could play around this sucker. If you don't have one yet, you need to get one. End of story. Here's one of the most important buttons right there. You know, I got to figure out how to make it actually focus itself. Oh, y equals. That makes sense. That's going to be one of our most important buttons, y equals. And then I got some stuff in there already. Is this working all right? Can you guys see that relatively well?
Yep, I can see it perfectly.
All right. I haven't done this yet. Let me do this. Okay. Oh, there we go, Jeff. Look at that. That's kick-ass. All right, sorry. Sorry. Let me clear this out. So I don't know what I was doing earlier. Just like, I don't know. When I was 6 and the tax man came to our house, I would take his calculator and play with it in the corner. He's like, I wonder what Jeff's going to do when he grows up. All right, so if I put in here, let's do something like, let's do 800x minus, what do you got, Jeff? Minus 750. I like it. Right? So, of course, that's just going to be a straight line. But if I hit, so if you're playing along with me, if you got your graphing calculator or emulator or anything, if I hit graph right now, I have no idea what I'm going to see. So a lot of us probably will see this. Yes? Some of you guys could see almost anything else depending on how your calculator was set the last time somebody graphed something. So let me make sure everybody who wants to be playing along is able to play along. So that's what I put in there. That's the function I put in there. So what's one thing about this line? If I want to know, if I want to see where it hits the y-axis, I want to have that show up on the screen. Why can't I? So just to make sure everybody's got the same picture I do, if you hit zoom, zoom standard, number 6, then everybody should look like this. Yours might not be blue because I got the fancy schmancy one, yeah. But try to contain your jealousy. Now, this only goes from -10 to 10, -10 to 10. How far down do I have to be able to see so I can see the y-intercept of this?
750.
750, yeah. So where I go to control that is window. Winder. Don't worry about down here quite yet. Where's my finger? There you are. Finger. Okay, get away. So right now I can just now which one do I want to switch so I can see further down?
The y minimum.
Yeah, y min for right now. I want to be able to see further down. We probably also want to be able to see further up. Because what's my slope on this thing? Let me go back to it. What's my slope on this sucker?
800.
800. So you can already tell, I mean, if I put a 1 in for x, I'm going to be at 50, right? And if I want to put a 10 in there, I'm going to be way the shit up there. So let me see. What's going to make some sense here? Who's got a suggestion on what to do for y min? I mean, you could just make it negative 750, right? But that's not going to be good enough. I want to be able to have that in the middle of the, so maybe I'm going to do negative 3,000, just to put something. Now be really careful. There is a minus key and a negative key, and they are hardwired differently. They do exactly what I just said they do. That subtracts, and this one is negative. If you use the wrong one at the wrong time, it's gonna freak you. It's either gonna give you a syntax error, or it's just gonna like give you some weird shit. Let's just see what that did for me right there by itself. Now that, I can see where it hits the y-axis, but is this a very decent, is this a good looking graph?
No.
There you go. No, so I want to kind of balance it out. So let me go ahead and make y max. Let me just balance it out. And you make y max 3,000. And now it's kind of like put the x-axis back in the middle of things, and that looks a lot better. I could also, just to show you some other things in window, I could change the y scale. Maybe I want the y scale to go by, what do you want, Jeff? 250. Why not? And now it puts a little tick mark for every 250. Are you guys with me? That wasn't really that necessary, but it's just aesthetic. Does anybody else have a button that you might have pushed to make the calculator make the image better? I don't know if you ever did zoom. I'm not sure what it's going to do with this. I personally always hate using this one because it kind of does shitty jobs sometimes. But zoom fit sounds like it might be a good one to try. So let's see what it does. All right, I can live with that. Zoom fit's not a bad thing to try. Okay, I like it. I think that's all we have to worry about at the moment. So later, not too far from today, we're going to learn how to do stuff like find intersections, find intercepts, all that kind of stuff.
I have a question.
Yes, sorry.
For the homework, do you just want us to plug in the equation and then have the window that they're giving us and then like
Yes.
take a picture of our calculator and submit
Yes.
it?
So the function they give you is x squared. So you put that in here. And then they tell you what window, that's the window for the x values, isn't it? So that'll be x min to x max that they tell you. And they want you to figure out what range you should use. So if your function is x squared, and you're going from negative 100 to 100, you can probably figure out what your range should be. You're like, how far up are you going to want to see? Does that make sense? No?
Yeah, I understand. So you want us to find the range and then take a picture of the graph that pops up on our calculator?
Yeah, this is the nice thing about, I like that. This is the nice thing about these kind of problems. You don't have to like sketch a graph and turn it in. You can just take a picture of the calculator and then submit it. I love it.
Okay, I understand. Thank you.
Kick ass. Now, okay, that's enough of that. All right, let me see. I'm gonna have to focus again here in a minute. Hold on. Oh shit, that's the wrong way. Was I upside down? I have no idea. You can't see anything. Oh shit, this is like, all right. I was gonna say it's like, I'm not gonna say. All right. Oh, let me see where's, okay. Anything else from homework stuff? Going back to chapter 2. Oh, all right. So there's a couple of levels of question there, Vanessa. Are you talking about specifically the quadratic formula, or do you just mean when you square root an equation to solve it? I think that's what you mean. I'm sorry, did you just click yes? I don't know. Quadratic formula, okay. Ooh, okay. I don't know if you want to, do you guys feel like re-deriving the quadratic formula right now? Maybe not. Okay, so the more important question is, why is there a plus or minus when I take a square root? That's kind of related to the quadratic formula's plus or minus existing there, to be honest, because it shows up once we take the square root of both sides. Are you with me? I think that might be more directly what you're asking. So there's several ways you can examine that. You know, all these new colors. Let's see what this looks like. Here. Now watch this. I don't think we talked about this before, but what do you square? You can do it, Jeff. What do you square to get 25? Yeah, that's part of the answer. What else? No, you're fine. 5 works. You square 5 to get 25. What else can you square to get 25?
-5.
Negative 5. Or written even better, plus or minus 5. So when you see this in English, it looks like this in Mathish. That question looks like this. Well, let me try again. There you go, John. That's better. So 25 in the question. Okay, okay. You guys kind of with me? Is everybody cool with this here?
Yeah.
Either one of these squared is 25, so you have to be cool with that. So if I solve this equation and it is this question written in Mathish, I better get those 2 answers. What's a different way to solve this than taking the square root? I could instead do this. And then, of course, I can do this. And then, of course, I get my 2 answers very directly, right? You guys, is that cool, Vanessa and everybody else? So if you don't want to do all this work, you could just take square root, but now you got to put a plus or minus there because you sort of skipped a lot of stuff that showed you that's the shortcut. That's just part of the shortcut. Kick ass. That is the problem with jumping to this before you've done problems like this. If you do many like this, then you know that should have 2 answers. So that's a little bit less freaky. Then. Okay, I like it. I like it. Anything else that's been troubling anybody for a while, or? So put a plus or minus in the square root because it'll always be the answer in a positive number. I'm not really sure I understand that, Jose. So even if you had uh-oh, purple don't want to come off. All right, purple. Oh, crap. Purple just messes everything up. I'm not sure what you mean. If I had this equation, I would still put a plus or minus. And I would just get complex answers, right? Is that okay with everybody? You guys all right out there? Jose, is that all right? Do I? Okay. All right. I wasn't sure what the question was. Okay. Super. So anything else, guys, before we move on? Hopefully, if you're getting into chapter 3, it's a little more focused, for sure, than 1 and 2 were. 1 and 2 were just, they were a review section. They got a ton of stuff in them. Chapter 3 is a lot more focused. So that should be a little bit simpler to keep on top of. All right. So let's get back into this. There you go, Jeff. lost somebody. Somebody left. No. Oh, okay. Let me see. Where do I want to be? And we did 3-2 last time. I think there was one thing I didn't get to talk about in 3-2. Yeah, just to remind you guys. Let me see. We talked about how to find the domain and range from a graph. We talked about how to find the domain from a function that they give us, right? You just say it in English, write that down, solve it. So for a quick example, how would you find, oh man, why do your fonts disturb me? Your lack of understanding of fonts disturbs me. All right, this one's easy, good Lord. This one should be easy. What's the domain of this one? And I know I just prepped it, so you're like, I'm not going to say a damn word. He just said it's supposed to be easy. That's a trap. Screw that. It's a trap. Anybody know the domain of this guy?
Would it be negative infinity to infinity?
Yes. And let me see. Who's asking me something? How do you find the domain range that makes a W-shaped graph? Are you looking at something specific, Amber?
Sorry, I didn't want to interrupt you. On the homework assignment, it was number 33 on 3.1.
Oh, 3.1. Okay, hold on.
Or I'm sorry, 3.2.
3.2. Okay, so 30. What was it again? 30.
33.
This guy?
Was I looking at the wrong one? Which one makes a W shape?
Let's see. Who's looking like a W?
Other way. There's definitely one. I'm not
There
that
we
crazy.
go.
That
Oh,
one.
that guy.
36.
All right, that's my graph. That's W for Waller. Whatever, Jeff. All right. This is also the long ask, right? I don't know. So all I want on this one is the domain and range. Is that right? For the
Yes.
following, yes. Okay. Okay, this is where students, and you know, there's a ton of places for students to overthink. This is one place where students overthink a lot. Once I go from here to there, I'm done with the range, because then it just repeats shit that I already know. Does that make sense? So it's like,
Yeah, that's where I was confused. I wasn't sure if it was like multiple ranges or
now,
not.
one thing I just noticed is, I think out of the corner of my eye, I thought that was a closed circle, but you see how that's an arrow?
Yeah, so that side goes to infinity.
Yes, so the range goes up to infinity, but you can see exactly how far the range goes down. So when you're looking at range, you just care about how high does it get anywhere and how low does it get anywhere. So I don't care that it's down there and then down there again. All I care is that somewhere it hits -4 and it doesn't ever get lower. Does that make sense?
Yes. So
And the
this
main,
one,
oh, go ahead.
yeah, it just kind of, because it starts at 10 and then it goes down and then it goes back up. So how would you
All
write
right, so
that?
what's
As
the
like,
lowest output? You always start at the, so that's why I said have the little dude start walking on the y-axis. What's the first place he sees it? -4.
-4.
And
Okay.
he never loses sight of it because it goes up there all the way forever.
Okay, gotcha.
But the domain, where's the first place he sees it? And this is, I guess they said to give estimates, right? Or did they even say that? This is a bit of an evil problem. Right, the domain, no, but you're gonna have to give an estimate here because, here we go. That's in the middle of this guy, right? So you'd say the domain starts at what? I'd have to say
2.5 or 2.5.
-2.5, and what would be on that? What symbol?
So parentheses.
Parentheses, 11. And then, of course, does the domain ever stop? Because if you have the little dude walking, he sees it, and however far over he goes, it's going to be really high up there. But my little dude has got infinite sight. So as long as it still exists to the left or right of him, it still counts for the domain. So whatever this x value is right here, it does have an output. It's going to be way the shit up there, but it's going to be there. You guys okay out there? It's always okay if the answer to that question is no. Follow-up questions are fine. Okay. So let me try to remember. Where was I? Oh, we did talk about piecewise functions. So you're just going to have to give those a try. I gave you a procedure to follow to do those. I think we did that one. That's the last one we did. And then that was it. Yeah, good. Okay. All right. So let me stop for a second. Before I get into 3-3 officially, there's a lag on my camera. It's freaking me out. Any questions from 3-1, 3-2 before we get into 3-3? Okay, not seeing anything. Jeff, you got to do it like this. There you go, buddy. So we did sort of have a little bit of a preview of 3-3, all about slope. And here's the equation. And do you guys see how it's just y2 minus y1 over x2 minus x1? I mean, f of x took the place of y. So that's just a little more formalized definition. So this doesn't necessarily have to mean it's a slope that the line, that it's just a straight line. It's a slope between 2 points on a curvy-ass graph, possibly. So let me see if I can find a visual here. Yeah. So if I want to know the slope between, let me see. What did it say? Oh, perfect. Between there, where x is -1, and there, where x is 2. Can you guys, let me see if I can, let me first make it so you can't annotate. Only I can. Let me change the color. There we go. Blood red. So I want to know between that point, right? Because it says from -1 to 2. So -1 is there, and 2 is there. Just take a minute and figure out what that slope is. Little drops of blood. Sorry. I think I need to watch a horror movie or something, get something out of my system. So everybody understands you're doing work right now, right? This is so weird. Just a wall of names. So a function itself is not a line. That doesn't matter. I'm just finding as the crow flies between these 2 points. So you can see why a function is what it is. So if I do f of 2 minus f of 1, sorry, -1, all over 2 minus -1. Right, that is y2 minus y1 over x2 minus x1. That's what that is. Any questions on that?
Isn't y1 4?
I haven't put them in yet. It's f of 2 minus f of -1. So what is f of 2, for example? What is f of 2? So do you see how this is f x2 minus f x1 over x2 minus x1, right? Good old slope, rise over run. And what does that equal? What is f? Well, what is f of -1? Go ahead and tell me. What's f of -1? 4, right? Are you guys with me? That's what f of -1 is 4. And what's f of 2?
1.
1. And then, of course, 2 minus -1 is 3. And it makes sense on a couple levels. It's definitely a negative slope, and you can actually see down 1 over 1, down 1 over 1, down 1 over 1. That's a -1 slope. It makes sense. That slope I found doesn't have anything to do with the function as a whole or something. No, it's just that's the as the crow flies between those 2 points. Okay. So that is how you use. So they can give you any function they want to and give you any interval they want to, and all you're doing is y2 minus y1 over x2 minus x1. That's all you're doing. Right? What is this point? Let I'm getting really kind of worried that nobody understands and nobody knows what to ask. That point is -1 comma 4, right?
4.
And what's this point?
2 comma 1.
So wouldn't this be 1 minus 4 over 2 minus -1, 2 minus -1. If you're trying to find the slope between those points, that's all that's doing. That's all that's doing. That's it. So if this represented the position of a car or a person or something, so they're at this position here, and then they're at this position there, this would be the actual average speed, average change in position. So it's the rate of change. So whatever this is, so what units would this have if this was feet and this was minutes? What units would this have?
Feet per minute.
Feet per minute. There you go. So it'd be an average speed. That's all you're finding. So if you find an average speed for a long trip, does that mean you went that speed the entire time?
No.
Hell no, right? Because what happened in the middle? You stopped, used the bathroom, you stopped because something flew out the window, you stopped to look at the biggest ball of yarn in the universe, whatever, right? So of course you didn't go that speed the whole time. You went faster and slower and fast. All right. So the whole graph is doing whatever the shit it is. I just want to know the average between two given points in this case.
I think the part that was confusing is that looking at the graph as a result of the function and not seeing an equation for a function. I think that's what was the confusing part of it. Because once you figured it out and you're like, the graph is the function in action, then you can find all the information you need to solve the answer.
Yeah, so they don't have to give me what G of t actually is because they've actually given me all the answers for it that I need. Is that related to what you're saying?
Exactly.
These really should be G's. I don't know if that's troubling anybody. That's my mistake. I mean, this is a G function, so I should have put G's up here, but G's. Okay, I'm going to clear that mess there. Go away. So they can give you any function they feel like, and you can do that same kind of thing. And you can do it from a table. Find her average speed over the first 6 hours. So take a minute and see if you can do that. This is just the table, but it's another way to give you points. They don't have to plot the points. Can you find the average speed for the first 6 hours? Ooh. Oh, you can see the answer down there. So she started 10 miles away from home, maybe. And then after 6 hours, she's 292 miles away from home as the crow flies. Oh, okay, Emily. I was wondering what that, because I hear a noise whenever somebody leaves. So I always get a little sad when I hear a bunch of leaving noises. Somebody's just getting booted out because of the internet. I can understand that. How are you guys doing out there? Are you guys seeing how to do this? And again, it is just y2 minus y1 over x2 minus x1. So you could look at it either way that makes more sense. So here's my second point, and here's my first point. So what goes on top?
292 and 10.
292, y2, minus, or you can say d of 6. I can put that up here, d of 6. This is always good, Jeff. Just write more because your writing is like art. Over 6 minus 0. Right? That's f of x2 minus f of x1 over x2 minus x1. So d of 6 minus d of 0, which is 10, divided by 6 minus 0. What do you guys get?
47 miles per hour.
Yeah, I get 47. So let's see. Oops. I don't know if I can do this. Oh, shit. Yes, I can. That's going to come with me. Ooh, look, we got it right. Yay, look at us. And be careful. Don't make me be a jackass. If you don't put units, I'm going to be a jackass, and I'm going to say light years per second. You know, I'm going to just, you know, I'm already a jackass. Don't make me be more of a jackass. Unless you want to see how much of a jackass I could be. I could be a big time jackass. Is there any questions on that? Is that all right? So a table is just another way to give points. A graph is just another way to give points. So all the work should be very similar. I'm going to erase all this. I could do it this way. I learned the quicker way. Okay, okay. Blah, 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 blah. Oh, yeah, here. Good, good. So now you could see. Let's do this one. This one looks more interesting. I love this problem. I would. Find the average rate of change for this function on the interval 1 to 9. They don't give you a picture. They don't give you points. So evil. Just to remind you guys. Here, let me put that. If you don't have the book open or you haven't written it down yet, let me show you this again. Give me a second. Don't freak out. Right there. That's the average rate of change equation, which again is really just y2 minus 1 and 1 over x2 minus 9. It's not different. But if you look at it that way, when they only give you this, it makes it relatively simple to do. So that's why it's good to have multiple ways to look at the same idea, because they could present you with something in multiple different ways. So take a minute, try to figure out what this is.
An example for it or number 2?
I'm sorry. What did I say? I'm sorry. It was try it number 2. I'm sorry. I think I shouldn't have went up there because then I forgot where I was. Try it number 2. This guy. We'll do that one together. So what goes in here?
9.
Yeah, f of the end minus f of the beginning. And down here just goes the end minus the beginning. The change in the outputs over the change in the inputs, which is a rate of change of this per this. Okay, maybe, maybe. And then how do you figure out what f of 9 is?
You can just plug it in.
Yeah, plug that shit in. So they didn't give me a graph. They didn't give me a table. Oh, I got to do some work, man. So f of 9 is
3.
3, right? 9 minus twice square root of 9. 9 minus 6, 3. And then what's f of 1?
-1.
-1, I like it. And of course, 9 minus 1. All right, I like it. And of course, you get 3 plus 1 over 8, so you get 1/2. Now here, you don't need to use units because this isn't a real physical problem. There's no units. It's just a mathematical problem. But you can still look at this as 1 up for every 2 over, because that's rise over run, right? There's just no units. So it's more like a position. 1 position up for every 2 positions over. I don't know, that's not the best way to say that, but too bad for everybody. Can't be good at the Englishes and the maths. Okay. Is that all right? I'm going to take that away. It's not a lot there, so it should be okay. It's going away now. All right, all right. So if I remember correctly, there's only a little bit more here. Remember we did talk about this graph, the finding out the increasing and decreasing? Maybe we should do another problem like that and include, can somebody tell me, if I say this, is there an absolute maximum to this graph, to the outputs? Is there an absolute maximum output? What's your gut tell you? No.
No.
Why? Because that just keeps going up and up. It just doesn't have a ceiling. But is there a local maximum? Yes. What's the local maximum? Good. 16 is the local maximum. Where does it occur? Yes. So
-2.
what? I'm sorry. Say again. Sorry.
-2.
Yeah, exactly. -2. So when I say what is something, that's normally an output of a function. And when I say where does it happen, that is an input answer. So where does the maximum happen? At x equal -2. What is the value of the maximum? 16. Kick ass. And of course, you could say the same thing for a local minimum, right? Same thing. This is a beautifully, it's got some nice symmetry through the origin here. Let me, don't feel bad if you don't know. Does anyone know what you call this kind of symmetry? Do you guys see the symmetry here? It's not symmetric in a way that we're used to. It's not like a mirror image. It's really weird. Does anybody remember even symmetry and odd symmetry? So a very simple symmetry would be like a parabola. Parabolas are obviously symmetric. They're mirror images if you pretend like that's a real parabola. Somebody sat on my parabola. Give me a break. But like the mirror is here, right? And in fact, a really easy way to remember what even symmetry is if it's an even power polynomial thing, then that's even symmetry. X to an even power. So it's even symmetry if the mirror is here. So this image is mirror image here. This is called odd symmetry. Does that look like an x cubed kind of function to anybody? Just me? Just you, Jeff. But doesn't an x cubed look like this? This is a pure x cubed, right? This is a pure x cubed. This one has got extra terms, x cubed plus x or some whatever the shit. Anybody with me at all? Are you guys all right?
Yep.
Just a little side note, by the way. It's going to come up later. I'm sorry, Jason. But this odd symmetry is symmetric through a point. So if I take a point here and I draw a line through the origin, I'll find its mirror image, especially if that line is straight, which is a very difficult thing for me to accomplish. So if I take any point and go through the origin, I'll find its mirror image. So that's a point mirror. That's so neat. So this arrow, if I go through the origin, there it is. There's its mirror image over there. It's the exact opposite output. All right, it's enough of that. Enough of that. That's a little side note anyway. Okay, let me clear all my little stuff here. Go away. Let me see. Let's do one more of these decreasing, increasing thingamajigs. Oh, here's a good one. Oh, this is a good one. All right, Jeff, calm down. Take a minute and try to write the intervals where this thing is, it just says increasing. Just worry about the intervals where it is increasing. Remember, where means which variable, which axis.
X.
That's right. It's the X. X-axis, that's right. So you want X values for this. So there should be two intervals that you'll find for this to be increasing. All right, so this is a you see it or you don't kind of question here. Not a lot of work here. Where's the first interval start where it starts to increase?
At 1.
-2.
At 1. I'm not asking what the value is where it starts to, I said, where does it start to increase? That's x-axis shit. If I say, what is the value at this place? That's y, that's output. So where does it start to increase? At 1. In fact, I got to keep this, there you go, Jeff. We don't count the turning point as increase or decrease because it's flat. And then where does it stop increasing right after it goes? It's increasing, and then it stops increasing at
3.
3. I pretend like that's a 3. 3, you are my bane. You are my nemesis. Commas 2. Oh my God. All right, I'm gonna stop. Or what other interval?
4 to infinity.
Yeah, 4. It looks like 4 to infinity. I like it. By the way, can infinity ever have a bracket on it?
No.
Hell no. If it does, I want to see that shit. Because what you're telling me is you can make it to infinity. I want you to show me that shit. Even if it blows my mind and I go insane, I want to see that shit. Anybody ever seen that movie, Powder? I always say if you get to infinity, you become energy like Powder did at the end. Oh, I just spoiled it. Sorry. Shit. Maybe don't watch it. I'm sorry. All right, sorry. Is that all right? So how many local mins does this have?
2.
2. And of course, how many local maxes?
1.
1. Does it have any absolute mins?
Yes.
Yes. Right? That is the absolute lowest that this graph gets. Why can I assume this doesn't do any turns anymore? Because once you put that arrow on, it means it keeps going in the fashion that I showed right before the arrow. That's what that means. So you're not going to say, well, my turn over. No, no, no. It's going to keep going up forever. Too bad.
Is it also increasing on the left? You see the arrow going up?
That is, yeah. It's increasing as you move back. Yes.
So would you write that as well for the answer?
For what answer? Sorry.
For just saying if like name everything that's increasing, like all the numbers that are increasing.
Now you gotta be careful. See how I had to qualify it by saying if you move backwards, that does look like it's increasing. But of course, how do we read anything in certain countries, especially in America?
Up and to the right.
Yeah. So I know other countries read it differently, but we read it this way. So it's got to be increasing as I look this way.
Okay, got it.
I like it. Otherwise, anything could be anything we want it to be. I'm looking at it this way now. So if the profit's increasing, boss, and you're like, you're fired. All right. I'm going to clear that. Clear? Okay. Got to get rid of that. Okay. I think that's all I wanted to show you here. It gets into some stuff here. Well, let's see. Maybe I want to, all right, maybe we can do something here. Yeah, let's do, yeah, this is a funky looking thing. I like it. Ooh, look at that, dude. Okay, let's see if we can do this. Well, sure, yeah, I like it. All right, here we go. Anybody wants to play along? Let me see if I can do this without taking my phone down again. So go into y equals. Oh shit, this is gonna suck. I gotta learn how to make this thing focus by itself. I got this app that lets my smartphone be a webcam, but it doesn't have an autofocus. So go to y equals, and then type in there, hey, I'm on a war. Type in there 2 divided by x plus x divided by 3. Because, I don't know, it's kind of tiny, but you guys can see this function right here. I'm sorry. Do you guys not talk to fuzzy people? Here you go. Can you get? I guess you guys can see that function, right?
Yeah.
Okay. All right. It's like, what's going on? Okay. So type that bad boy in. Shit. Hold on. There we go. Now, if you hit graph, it's gonna go freaky. Especially based on our last graph. I mean, look at mine. Mine's like, doesn't know what to do for me. You can't even see it. It's that little blue line in the middle. because the window is set up horribly, sort of like this window. Bam. Okay. All right, so what have we learned? What's the quickest way to try to make it look good on the screen?
Zoom 0.
Zoom fit.
Zoom fit. Zoom, and I think you're right. It's 0 for me. It might not be 0 for everybody. So if you go to Zoom and you scroll down, Zoom fit in the list, for me it's 0, so you could just hit the number 0 like somebody just said. And it actually does a good job. Sometimes it does a not so good job, but then you can go in the window and adjust it. But I get this shit. Hold on. There it is. There it is. So I get what the book got basically, which is nice. Now, can you guys see, is there a local maximum?
No.
Yes, there is. So when I say local maximum, that means if you look through the graph and you look at a little like, this is the real technical term. If you look at a neighborhood, so watch this. If I look at a neighborhood, it keeps going up here. See how it increases? Isn't there somewhere where it starts to decrease? Isn't this increasing? And then over here is decreasing. What's that mean? Has to happen in the middle. It has to, somewhere in here, I would guess negative 2.3 is my complete out of my ass guess. I don't know, maybe it's negative 2.5. Somewhere in here, there's going to be a maximum. Are you guys with me?
Yeah.
Yes.
No, sorry. Good. There's no absolute max, of course not. And there's no absolute min because it goes up forever there and it goes down forever there. So there's no absolute, but there is a local. Now watch. Here's how to find the local max in your accumulator. This is going to suck, but oh well. So if you hit, do you see above trace where it says calc? So the whole first row is all graphing stuff. So if I hit calc, I'm just going to stay fuzzy for a while. If I hit calc, that'll give me the chance to calculate stuff graphically. And look at your options. Obviously, I want to do which one?
Maximum.
No, wait. All right. So yes. So if you hit the number 4, something very interesting is going to come up. So it's going to say, it's going to ask 3 questions. What is your quest? No, it's going to say left bound. So I got to move the cursor. This is where it's going to suck a little bit. Can you guys see my cursor moving around? And I'm pushing the over arrow. Up and down won't do shit. Up and down moves between functions. How many functions have I graphed? Be careful. How many functions is this?
1.
1. Beautiful. So if I hit the up and down arrows, ain't gonna do shit. It's gonna try to bounce to the next function. There is no next function. I like being blurry. This is neat. It's like personally drunk. All right. So left, I want to move the cursor until it's definitely left of the answer. So I'm going to go, the answer I think is in here somewhere. So let me go over there. So now it's to the left of the answer. Are you with me? And hit enter. And do you see how a little arrow opened up there? So what you're doing is you're going to go left and right and then give it a guess. And that's going to give it a little neighborhood to investigate. So now the next question, of course, is right bound. So now I want to hit the over arrow until I'm to the right of the answer. Oh, shit. I went way too far. Okay, hold on. It likes to go really fast over there. All right, that's a pretty good one. I'm definitely to the right of the answer there. Enter. And then I want to give it a guess. So then I'm going to move it right about there. That's my guess right there. Enter. And then it gives me the actual answer, negative 2.45, it looks like. Yes. Oh, shit. That was a lot. I know. Has anybody out there ever done that before?
No, that's the first time I've seen that.
Anybody else? Nobody?
No.
One
I have a
person
question.
says yes, one person says no. I'm sorry, go ahead.
So it says calculate the local extrema. I hope I'm pronouncing that right. Right. So would the value be the x or the y?
All right, oh, here, up here. All right, finding local extrema. So let's look at the exact question it asks. Use the graph to estimate the local extrema of the function, determine on what intervals, blah, blah, blah. So when they just want the extrema, what you normally do is you say a max at blank, a max of blank at blank. So like I would say, the one we just did was a minimum. So let me say that again. This function attains a local, God, come on, little dude. Focus. Focus. Focus is broken. Oh, there we go. Holy shit. It attains an absolute max. It is a max. I'm sorry. It attains a local max at 2.45 of whatever the y is. Where'd it go? Oh, I see. That's why I can't see it. Negative 1.63, blah, blah, blah. So if they just say find the local extrema, that you have to give both parts. If they say find the extreme values, those are outputs. If they say find where the extrema happened, that's inputs. If they just say find the local extrema, you give both parts. You say it hits a max value of blank at x equal blank. Is that cool?
Yeah, thank you.
In fact, let's see what they say here. All right, here's their stuff. Oh, here's the minimum. All right, here's the maximum. Sorry, so that's what we just did. And that's the interval. That's the interval that it's doing stuff. They actually didn't give the example, did they? Well, that's good. That's nice. They didn't actually state the answer. I guess they're assuming this is their answer good enough. But that's how you have to give both parts for that, because they didn't specify which piece they wanted. All right. Blah, 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 blah. Okay, so all these other things are the same. They've done this many times. This seems to be important, these shapes. And now they're kind of adding in some more ideas about where it's increasing, decreasing. So we've seen all these shapes before. You need to know these shapes. Oh, is it still blurry, Brian? I'm sorry. I got it. The autofocus thing I got to do manually, come to find out. So the word auto doesn't really belong in that. Yeah, and then this absolute max and min, please let that be simple. You just got to see what's the highest it gets and what's the lowest it gets. It's sort of like finding range, right? It's very similar to finding range. Are you guys, anybody not with me? Local max and mins get freaky a little bit sometimes. Absolute maxes and mins are generally a little bit easier to find. Okay. Blah, 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 blah. There's just more examples. Let me know if you need more examples. It's always good. And that's it. So this section has got stuff about extrema. It's got stuff about increasing, decreasing. And this is also where you've got the the rate of change. So 3 main ideas in this section. I do want to get at least a bit of a preview of the next section, unless somebody has a question or a request.
Can I ask one more question about the same problem we were just on?
No, I'm joking. Which one were we just on? Oh, is it? Hold on. This
it was
one.
the one that had like the 2 different lines. Yeah. So is the local maximum? Would it not be the one on the right line? I know technically they're the same function, but like the line on the right technically goes higher. Does not now count as a maximum?
Here's the thing. This is the local maximum because locally it is the highest point. This is the local minimum because locally it is the lowest point.
Just local to what exactly? When I think local,
itself.
I thought that just meant like what you were seeing on the...
When I say local, it actually means, it does mean like they kind of do it here, there. Compared to the other points near it. And what does near mean? Well, that's a little vague, but normally it means, 0.000001 that way and 0.00001 this way. Because I want you to, that's a very good observation you just made. Local minimums can be higher than local maximums, for damn sure. So can't a valley be taller than a peak of a mountain nearby? So this mountain peak is lower than this valley. I think somebody said something in the, yeah, Joshua, you got it. So this is a valley and this is a peak. But the valley could certainly be higher than the peak of this little mountain, right? It totally could be. And geographically, it could happen that way too. So is this location higher than this location? Yes. Is this still a local minimum? Hell yeah, because locally, everything else gets higher than that point does. And the same thing here. Locally, everything is lower than that point is. Is that all right?
Yeah, I guess that makes sense.
So local min could be bigger than a local max, but an absolute min could never be bigger than an absolute max.
I have a question as well.
Yes.
So would that also, like, if you had one line that had multiple valleys and peaks, would those each be local maximums, local
I
minimums?
like it. So later this semester, we're going to talk about sine waves and stuff, right?
Oh,
Like
yeah.
stuff on oscilloscopes. So pretend like these all have the same height. So you could have a function like a sine wave that has an infinite number of local maxes, and they're all equal to each other. That's why there's an infinite number of them, because it's an infinite way high.
Okay.
Sweet. And the same thing for
Awesome.
the mins, of course.
Thank you.
Excellent. I like it. Okay. And then if you pluck like a guitar string is interesting because it has oscillations that decrease over time, of course, thank God, because otherwise every guitar that's ever been plucked, it would still be going. But thankfully, friction says, we got that, don't worry. Okay. Some alternate universe where guitar strings never stop. Who invented these things? All right, so, okay. That's all I wanted to say on this section. So you got to get in there and try it out. But like I said, I think you're going to, if you started doing chapter 3, you must have noticed it's a little bit easier than 1 and 2. It's a little more, it's a lot more focused, right? So that should be very, very nice shift. I do want to do at least a little bit of a preview of 3-4 and maybe even a little bit of preview of 3-5. Let's see if I can push it. So this guy, the idea with this one, we've actually seen stuff like this already. Let me just throw this at you, this very first thing. Do you see they define what f of x is here, they define what g of x is there. Does anyone think they could do what this wants you to do? There's another way to write that less compactly. So another way to write that, the minute I write this the other way, you'll know exactly what to do. So the other way to write this is g of x minus f of x. But we just chose to write that in this format, so we have to write x one less time because we are that lazy. Math people, I'm trying to say. So can you take a minute and figure out what that is? I mean, so it does exactly what it seems like it wants to do. It's take the f function and subtract it from the g function. That's exactly what that means. Thank God, because that's what it looks like it means. Do that, see what you get. I'm thinking that for tomorrow's class, I'm going to have kind of a group worksheet that goes over examples of problems we've done in chapter 3 so far. Because I really don't want to sit here and just be lecturing every time. I'm sure that kind of gets to you. So I've got a worksheet I've started putting together, and we're going to do that tomorrow as a kind of a review of everything we've done so far. Has anybody got an answer for this?
X squared minus x minus 1.
Yeah, let me see. Oh, shit, Jeff. Let me start over. Okay. So yeah, so you take g, no, come on. G of x. Now the one thing you got to be careful about is when you subtract f of x, you got to put it in parentheses.
Well, I didn't see that stupid -1.
Sorry?
I didn't see the -1 at the end of x squared.
Oh, I see. Yeah, I got you. So you get x squared minus 1 minus x plus 1. So you get x squared minus x. Is that all right?
Yep.
So do me a favor. This, I think, came up earlier. What is g of 2 minus f of 2? So you can figure out what g of 2 is, right? Which g of 2?
3.
Yeah. And what's f of 2?
1.
So then you get 2, right? So what this whole thing we just did is, well, I could do g of 2 minus f of 2. I could just put a 2 in that because this represents the result of any g of x minus f of x. So if you put a 2 in here, 2 squared is 4 minus 2 is 2. Same answer. Oh my God, holy shit. Right? Is that okay? So this idea of, so composition of functions just means, it actually means something different than this. This is algebra of functions, how to add, subtract, multiply, divide functions. So of course, what does your gut tell you you would do here with the functions? What would you do?
Multiply.
Multiply. I love it because when things sit next to each other, that means multiply. So you would just FOIL that bad boy out, right? No big deal. And this, of course, again, you just subtract it. And of course, what about this one here? Good Lord, Jeff, you're just writing all over the damn place. You're writing blue. This guy, what would you do with this guy?
It's division.
Yeah, you would just take this guy divided by this guy, and then could you do something with that? So if I write G on top of F, can you do something with that?
Factor the x squared minus 1.
Yeah, cool. So if you factor the x squared, you get x plus 1 times x minus 1, which cancels with that x minus 1, so you just get that. Woo! I don't know what you're doing up here. All right, that is definitely a football play. All right, let me take that away. But I mean, the point here is those do exactly what you would hope they would do. That looks like multiplication. All right, you multiply the damn things. That looks like subtraction. All right, you subtract the damn things. Thank the Lord, right? So what about down here? This is what a composition of function is. When you put one function into another function, that's where things get super nifty. Right there. So here's an example to give. F of x is x squared, g of x is x plus 2. So what's f of g of x? Well, what's g of x? X plus 2. So replace g of x with x plus 2, and then you put x plus 2 into f. Let me stop for a minute. This shouldn't be anything too desperately new. This definitely was in, like previous courses, but it might have been a while for some of us. So we did a problem the other day about that was even more difficult than this, but if I see f of x plus 2, I just take x plus 2 and plug it into f. That's all I do. So anytime you see f of g of x, you just replace g of x with what it is, and then you throw that into f. So let me do, let me see. Let me do something nifty to you here. What time is it? All right, this might be the couple last things that we do. Answer this one. I want to know what g of f of x is. So go ahead and do that. To g of f of x for these two. I'll wait. So we can write it as g of 2x plus 1, right? I can replace f of x with what it is. And then this, I want to plug into g. So my brain always goes to like Russian nesting dolls with these kind of things. There's something inside something inside something. So this will be 3 minus stuff. Because that's what the g function does, right? G of stuff is 3 minus that stuff. So if I distribute the negative, I'll get negative 2x plus 2. Is that cool? 3 minus 2x, 3 minus 1 is 2, yay! Now, do this. What is f of f of f of x? The function. I don't know if this is a plus for you or a minus, but end of the day, I'm a little extra loopy. So, I mean, again, I don't know if that Russian nesting doll thing makes sense, but it's sort of like the reverse of it. You start in the innermost. So this is f of 2x plus 1. So I'm not going to worry about this guy yet. I'm working inside. That's what our operation says. Do the inside first, right? So how do you do f of 2x plus 1? Where do I put 2x plus 1? I'll tell you where to put 2x plus 1. No. Where do I put 2x plus 1? Don't freak out. I mean.
Into the x value again?
Yeah, into the x value of f. That's all. So this will be f of twice stuff plus 1. That's what f always does to stuff. So this will be f of 4x plus 2 plus 1. So 4x plus 3. Is that okay? Jeff. Oh my gosh. My writing is about 6 years old. I like it. Is that all right? Is everybody still freaked out about shoving f into itself? I mean, that sounds like an empty threat that you would make to f.
No, that makes sense.
That
makes sense.
F doesn't give a shit what f is like. F didn't even know this is itself. F just sees numbers and letters, and it says, all right, take all the numbers and letters and plug it in where I have an x. And then this f is going to go, all right, take all those numbers and letters and plug it in where my x is. This is like math biology. So twice stuff plus 1. That's what f always does to anything inside of it. It always doubles it and then adds 1. So then I'll end up with 8x plus 6 plus 1, so 8x plus 7. Woohoo! Crazy shit. All right, not bad. Not bad at all. Well, we'll see. You got to get in there and try this homework out. Please understand, it's not a bad idea to leave some homework undone and get into new shit sooner and then go back and finish the old stuff, because you want to get into this stuff as soon as you can after the lecture. So don't go, I can't do this until I finish up. No, why not? Why not start this? Start it. Keep it going in your brain. Then go back to the other one, finish that up, right? Because I think people sometimes leave too much time in between lecture and when you start to do homework, and that's never a good idea. Ever, never. All right, guys. I think that's all I think I should do to you today. I'm going to clear that. Go away. Let me stop sharing. Okay, so if you have any questions, stick around. Otherwise, class is over. And in case you missed it, the quiz corrections aren't due until the final exam, and they're curved. So if you look at your grade, it's higher than what it says you're in a quiz. Oh, I'm sorry, Amber. Aw. Hey. All right, so anybody have any questions? Anybody sticking around?
Thank you.
What?
Thank you.
You're welcome.
Gabriel wrote a question about the homework problems.
I'm sorry, I missed that totally. Do we do all the problems? Gabriel, are you still there? Let me see, Gabriel. Yes, you're still there. So in Canvas, if you go into Canvas, there is a link on the left that says homework timeline sheet. Do you know about that? Let me show you.
Under timeline and homework, are you referring to the section exercises?
Yeah, yes, the stuff at the end of each section.
Okay.
Yeah, and the reason I don't put page numbers is because, believe it or not, the page numbers are different for the online version versus the PDF versus the textbook. Sometimes it is, and that's annoying as hell. So I'm sorry I didn't put page numbers, but
Okay.
yeah, they're just.
Yeah, I was about to do the problems.
No, not the intermediate problems in the middle of all the explanations. The stuff at the end of the explanations, yes. Is that all right, Gabriel? Was that Gabriel I was just talking to, or is that somebody else? Am I saying that wrong, or is that Gabrielle? I don't think it's Gabrielle. Somebody's chatting at me. Oh, okay. Finding domain. Are you talking about for a given graph or for a given function?
For a given function, for both. Like I'm still confused. Like how like where do you need to put the brackets at, or
All right. So, are you looking at a specific question?
it's just in general. Like if you were to give us like an equation or a graph, and you tell us to find the domain, just like that, or at what point?
Like how to write the interval
notation?
Yeah,
exact. Yeah, how to write that.
So that depends on, are there, let me, what am I doing? I am still sharing. So like here, I wouldn't really write the answer in interval notation because there's only one thing that's not the domain. So I'd rather answer it as x not equal to whatever. Is that cool? So I think you're probably asking more like if they give you a graph. Let's see, like this one we did. Yeah?
Yeah, like that.
So would I include -3 in my domain?
Yes, right? Because that's where it's starting.
But is it allowed to exist at -3?
No.
Because there's an
no.
open circle. Yeah, so you would put a parenthesis -3, and then that's the lowest x value that goes somewhere, and what's the highest x value that goes somewhere?
1.
And that's a closed circle, so I would put a bracket on that because that's included. So I always think bracket looks like the letter I for include, and parenthesis looks like half of an open circle for exclude.
Okay.
Now what about the range? The lowest is -4, and that actually is a closed circle. And the highest output is 0. What would I put on the 0?
Parenthesis?
No, because it actually hit 0 there.
Oh, so it's a bracket.
Yeah, see that one's your range is a little evil because it could have multiple places where it hits. So if it didn't go up, if it only went that high, then the range would have had a parenthesis on 0 because it wouldn't really get to 0, right?
Yeah.
But it did get to 0 here, so it doesn't matter what happened over there. Is that better? I don't know. So for visual graphs that they give you, it's all about is it open circle or closed circle. That'll be parenthesis or bracket, yeah.
But then when you give us an equation and tell us to find the domain of the equation, then we could plug that in, right, on a graph and then try to solve it like that.
I don't want you to graph them out then. If I give you something like this, I don't want you to graph it out.
Okay.
I want you to do it. So what can't happen here in this function? The bottom can't be what?
The bottom can't be a negative number, right?
No, it can be. It can divide by a negative number. I
Oh,
can't divide by.
oh, so divide by 0.
So the equation you set up is based on the idea of what's allowed or not allowed.
Okay,
So
that makes sense. Like if you were to divide, you can't have 0 in the denominator.
yeah. So technically, if I wrote this in interval notation, it would be negative infinity to 2. Don't include 2. Start over again at 2 to infinity. I always look at this as this little intermediate piece. I always call that skip. Negative infinity to infinity, skip 2.
Okay.
Yeah.
All right, so that makes sense now. Whatever number is included is a bracket, and whatever number is excluded is parentheses.
Parentheses, exactly.
Okay, that makes sense now.
I like that.
Sweet.
All right. How's everybody else out there?
I have a non-math related question.
Nita, what's up?
I got an email from you as John Waller, but you're Jeff Waller here. Which one is it?
So that's weird. Oh yeah, that's right. Because officially the school still has me as, they have me as J. Jeff Waller in some places. I am John Jeffrey Waller. That's my name. I go by Jeff. And I just can't get the school to respect it. I don't know. So,
No
my email
problem.
is jeff.waller. So when did it show up as John? I'm John in Web Advisor because they just like to mess with me, I guess. I don't know. So, but yeah, so don't worry, that's still me. Oh, if I send it through Canvas, it's probably John, isn't it? I guess that's probably true. I should have said something. Shit, people are all like, great. People are deleting. I don't know, John Waller, what the hell? Your brothers bother me, Jeff. No, it's me. Okay.
Appreciate it. Thank you.
Sure. Anybody else? All right. I'm gonna head out. I don't see any other questions. Oh, wow. Okay. Bye.